Okay, now I want to put it all together. Let's put our diagram up at the top here, and we'll spread it out. And let's look at what happens here, what's happening here, what's happening here, 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 and here. So A, B, C, D, E, and F. Okay. And let's look at what's happening in the membrane as each of those are going on. At A, you have leak channels. And secondary active transporters. And you're at minus 70. I'm not drawing the voltage-gated sodium and potassium channels because they're not doing anything. At B, we have the same set of potassium leak channels and secondary active transporters. But at B, we're getting some positive charge accumulating from somewhere else in the cell. Okay, and that positive charge is getting closer and closer to popping open this activation gate, but it's not there yet. Okay, what about at C? At C, we have enough now to pop open the activation gates. So at C, we have some potassium leaving, we have some sodium coming in, we have glucose, but there's a large number of these voltage-gated sodium channels, 100 times or more than 100 times more than these others. And so when those pop open, we wind up with not just sodium coming in, but much more sodium coming in at a much higher rate. And at minus 45, that's enough to open all the voltage-gated sodium channels. So at C, we open all those channels, and that's what does the first half of our action potential. Okay. At D, we're at around plus 30. The inactivation gates have closed. I'm not drawing the leak channels now. Voltage-gated potassium channels open, so sodium is no longer able to get in. But now potassium is leaving. So we were at plus 30. Potassium is leaving, and so we start dropping down. As potassium leaves, this gets more negative. And so on. So we're dropping down. Okay, so this is the second half of an action potential. And that's these potassium leak channels allowing potassium out of the cell. What's going on at E? At E, all our voltage-gated sodium channels are closed. Potassium leak channels have now, voltage-gated potassium channels have closed. And we're at minus 80. Remember, we're at minus 80 millivolts because there's still potassium leaving through the leak channels. But we don't get all the way to minus 100 because there's also sodium coming in with glucose and amino acids. Okay, so how do we get back to our original state? So to get back to our original state, voltage-gated sodium channels are closed. And the activation gates are also starting to close. Voltage-gated potassium channels are closed. Potassium leak channels are open. And secondary active transporters are bringing in sodium and glucose, or amino acids. And that brings us back to our original state with only potassium leak channels and secondary active transporters, and that drifts us back to minus 70. Remember, we'll be in the refractory period until those inactivation gates open back up. So while the inactivation gates are closed, we're in the refractory period. Those are the events of an action potential. And to practice these, to think about it, it is not useful, not helpful just to look at my diagrams. You definitely want to be looking through all of these stages on your own and be able to explain them from what's going on in A, B, C, D, E, and F.